Hello everyone. In this session we will discuss about cryptography. So cryptography is a field where we convert data into a secure format which is not readable by the unauthorized person. That's the simple definition of the cryptography. Now cryptography has four different branches, but only the two of them are mainly considered. But let's discuss the four of them. So the first one is the encoding and the decoding part. In encoding, we just translate the data from one character set to the other one. For example, I'm taking two different character set. First one is the ASCII, which has a limit of 128 characters. In ASCII, only 128 characters are defined. Now we have the second one, which is UTF-8. So in UTF-8, more than 1 million characters are defined, but we generally use the 2000 or 1990 or 1999 characters out of those 1 million, but the actual limit is more than 1 million as well, but it completely depends on the system. Right now 1 million. Okay, so in encoding and decoding, so encoding we translate it from one format to the another one, and the reverse process is called the decoding, the simplest definition. We have two different character set. First one is ASCII, second one is UTF-8, but in general case we don't use ASCII and UTF-8 because they are automatically performed by the system itself. We don't have to intervene manually for this encoding decoding process. For that, the main thing that we have to discuss is the base 64. So base 64 is another character set which is defined within the system, and inside base 64 there are only 64 characters defined, starting with the uppercase alphabets as A, then up to the Z, then lowercase a to lowercase z, then we have some numeric values from 0 to 9, and the last two special characters that are the plus symbol and the forward slash. Now let's take a simple example how we can convert the normal ASCII or UTF-8 character into the base 64. That's what just we need to understand. Now, as per the general standards, we have only 128 characters in ASCII and more than 1 million characters defined in the UTF-8. This particular page represents few of the characters, not all of them, but on this single page we have around 1,000 characters listed, and we have 100 pages similar to this one, so you can check all those characters as well. And if we check the initial 128 characters, we can see the last character is the same, the delete. So in UTF-8 the initial 128 characters are exactly same to ASCII table, so you can use ASCII or you can also use UTF-8 as well. It's all come to you. Now let's take a simple example. But before starting with base 64 encoding decoding, we just need to understand how the system handles the data that we enter, that is processed by the system. So for that part, let's just take a little dig deep into the system part. So let's say I'm using UTF-8 as my character set. Whenever I'm typing, let's say I'm just writing hello, right, and I save that file in the system. Now what system will do, system will convert this ASCII or UTF-8 character into decimal format, or let's say system will check the decimal representation for each and every character within the hello. So for simplicity, I'm just taking the capital H from the hello, right? System will convert the capital H into decimal according to UTF-8 that I'm using right now, and out of that decimal it will be converted into binary. It's a simple translation and how the system handles the data, right? Based on the character set, it will be converted into decimal, and out of that decimal it will be converted into binary, and then it will be stored, right? The same thing happens in the base 64 as well. So I'm just writing a simple structure how the data is handled into base 64. So let's say after converting the data into binary, for UTF-8 we use the pairs of 8 binary bits, right? But when we talk about base 64, it always takes pair of 6 binary bits, right? base 64 works on 6 binary bits pair, and UTF-8 works on the pair of 8 binary bits, right? So after converting the data into binary of 8 binary bits, we have to chunk it into 6 binary bits. We have to create pairs of 6 binary bits. For that, let's take a simple example. I'm taking hello as an example here. So let's convert the decimal or the binary representation for each character. Starting with capital H, we'll convert it into decimal, and for that I'm going to use an online table here. You can take it directly from the Google. Let's go with the hello. As we know, the initial 120 characters in ASCII and UTF are same, so you can take it as ASCII as well, right? So that's the decimal representation for the word hello. And for the capital H, it's 72. For E, it's 108. For L, 108. The O, 111, right? So I'm just writing the equivalent representation here. So 72, 101, 108, 108, and the O is represented as 1, 1 and 1. Now after getting the binary or the decimal representation for the ASCII, we have to convert it into binaries as well. So let's convert it into binaries. That's the binary representation for the capital H. I'm just pasting it right here. Let's do the same for the E, double L and O as well. All right, so we have the UTF-8 set, we have the decimal set, and we have the binary set, right? Now out of these binaries, we have to create pairs of 6 binary bits. So let's just taking 2 pairs initially, just to demonstrate how you have to create the pairs. So we have these 2 pairs. I'm just writing them in the same line just to give you the better understanding. So I'm creating pairs of 6 binary bits out of these 8 binary bits pair. Let's take the initial 6 bytes, 1, 2, 3, 4, 5 and 6. That would be the first pair. Now initial 6 bytes we have already taken. Now let's take the second 6 bytes. These are the second pair. Just remove the space. Then we have the 4 bytes here, and we will take the rest 2 bytes from this third one, so 0, 1, right? This is the representation of the first 3 sets that we will get from the word hello, right? Now these 3 values will be converted into decimal, and that decimal value will be compared in the base 64 table. Or if you want, you can directly compare these values in base 64 table, right? Let me just go here and check. So the first pair that we made represents the capital S. So let's just write it here. The second pair represents the capital G, and the third pair represents the capital V, right? So just for the verifications for the simple process, I have only converted initial 3 pairs, but you can follow the same process for any size of data, right? Now if we want to verify that we got the right results, I'm just doing the same process online. So I'm just using the base 64 encoder.org, and you can automatically or encode data online as well. If you want, you can use some command line tools as well. So it all depends how you want to use it, right? So let's just write the same hello, and if you check the results, we can see the initial 3 characters are S, V, S, G and V, as we got right here, right? So the general process is we get the UTF-8 characters, we convert it into decimal, we convert it into binary, and out of those binary we create pairs of 6 binary bits and then we compare it in the base 64 table. That's the simple general process. Now, a simple question arises, why we actually use base 64, right? The simple answer is, not all the characters are representable, not all the characters are printable on each and every character set. For example, let's say not all the Hindi words, not all the Chinese or Japanese words are printable if I'm using a English font, right? So to handle that, we use a common character set which is available in each and every language, which is common worldwide, right? And base 64 has that character set. Let me just give you a simple example. We will use encryption in upcoming sessions. So let's say if I'm encrypting this simple line, hi all, my name is Siddharth Sangwan. I'm just encrypting it, right? This would be the encrypted output. Okay. And when I'm trying to decrypt it, this is the result that I'll get. This is the result that I will get. Now, simply we'd get that we have this unknown character. We have these square boxes, right? Which we cannot type, which you cannot enter directly in the system, right? And which are not printable by the system, which are not printable by the character sets that we are using in our systems right now. So to handle these situations, we usually use a common character set that our system can take. So this is where the base 64 comes into play. So that's a general session about the base 64. See you in the next video.